Hello and welcome! In this lecture we're going to look at an overview of the most important parts of this game, the grid system. This will be the base system to handle all of our grid-based logic. Here let's inspect the design of the system that we're going to build before we actually start building. Okay, so here's an overview of the grid system. This is a turn-based grid game, so we need some way of handling the grid logic. We want to create a class that will separate our gameplay area into various grid positions or cells. The grid will have a certain width and height, and each cell will have a certain cell size. By the way, here's just a quick note, I'm calling this vertical axis the height just because I think it makes more sense since the grid is just a 2D plane, but in reality, due to how we're going to use our grid, we're going to place it flat on the floor so it will be alongside the XZ axis and not XY. So technically, this is actually going to be the length rather than height due to how we're going to use it. But like I said, personally I think height makes more sense because I usually visualize the grid in 2D. Okay, so we're going to make a grid with a certain width, certain height, and generate all of these grid positions. For the index of each grid position, for example over here on the corner we start off on 0, 0, then next to it 1, 0, over here 0, 1, 1, 1, and so on. All of the logic inside the grid system itself will be based on grid positions. And then we're going to have a function to convert a grid position back onto a world position. That function is where we're going to use the cell size for the grid and do some math to convert between a grid position and a world position. For example, if we define the cell size as 10 units, then on grid position 2, 1, that would be converted into a world position of 2010. The reason for doing this is so that the grid is more adaptable. For example, in our use case for this game, we're going to actually be using a cell size of 2 units. The reason for that is because just one world unit is way too small to fit a character, so 2 units feels much better. But at the same time, we don't want our grid to be using some weird indexes like jumping from 0, 0 to 2, 0. So that is why we make sure to keep the 2 unit spaces separate. We have grid positions and world positions, and we can easily convert back and forth. Also, for defining the grid position, instead of using just an int for the x and int for the z, we're actually going to create a proper struct to hold both those together. That is going to help keep our code nice and clean by working with a specific data structure as opposed to a separate x and a separate z. Also, let me point out that you could technically use the built-in vector2int. That one does hold 2 ints. However, it holds a xy and not an xz, so if we use that, it's going to be quite confusing. And also learning how to make a proper struct is a great thing to know how to do that can be quite useful in your own projects. So all of that makes the structure for the grid that we're going to build alongside the conversion to world units. And one more extremely important thing is how we're also going to define a class for a certain grid object. This will be a class that will be instantiated in every single grid position. The reason for this is that this class will help us store all kinds of fields and do all kinds of logic in the grid. For example, our class will have a unit field. That way we can easily get a certain grid position and check if there's a unit present on that grid position. And later on, when this whole system is built, we're also going to reuse the exact same grid class to handle pathfinding. So that is why we need to make sure we write our code with a really nice structure so we can reuse it in multiple scenarios. Alright, so this is the design of the grid that we're going to build. It's going to help us tremendously in managing all of the grid logic in the game. We're going to create a grid with a certain width and height. The grid has a cell size which is used in converting from grid position onto world position. And each grid position will have an object of a certain class so we can store any data we want and do all kinds of logic on each grid position. Okay, so this design we're going to implement. Now in the next lecture, let's begin construction.